Today we're going to write a program to score a game of bowling. We're going to do this with test-driven development. This is a kata that was made famous by Uncle Bob Martin. And it's a kata is basically an exercise to teach you how to do something. And it's based on repetition. So it's meant to be done over and over and over again until things become automatic. So you don't even think about it anymore. You can think about this as a way a piano player plays their scales. They don't do it because they're going to play scales every day, but the scale represents the notes that they'll be playing every day and how to get from note to note. So they practice the scales so that their hands are fluid enough to move from note to note. So that's what we're going to do today. And we're going to start from scratch. So we're going to start from a brand new Gradle project. So we'll do a Gradle init. We're going to create a library. We're going to do it in Java. We're going to use Groovy. We're going to use Jupyter. And BowlingGameKata demo. And that's that. All right, we'll move into IntelliJ. So in a game of bowling, the game consists of 10 frames. Each frame, the player has the opportunity to roll a ball. They have their opportunity to knock down up to 10 pins. The score for the frame is the total number of pins they knock down. Now, there's a couple bonuses that they can get into. If they knock all pins down with 2 tries, that's called a spare. And in a spare, they get the 10 pins plus the next roll. So if they roll 3 pins, it'll be 10 plus the 3. So they get 13 pins for that one frame. Now, if they knock all 10 pins down in the first ball, they don't roll the second ball. And then they get to count the next 2 balls, or the next 2 throws, on that frame as well. So if they roll a 10 or a strike, and they roll a 3 and a 3, that would be a 10 plus 3 plus 3. That's 16. And then they still get the 6 pins for the next frame. And then in the 10th frame, if a player rolls a spare, they get to roll 1 extra ball to complete the spare. Or if they roll a strike, then they get to roll 2 more balls. No more than 3 balls can be rolled in the 10th frame. So when we do test-driven development, we want to be very methodical on what we do here. So what we're going to do is we're going to start off. We have 2 code trees here. We have the main and the test. So we're going to start off with the test. We're going to create a new class called game tests. All right. So when you think about scoring a game of bowling, there's many ways that you can start. But when we go with test-driven development, we always want to start with the simplest thing. And so the simplest thing is we want to know that we can start a new game. So we're going to create a new test here. And we'll just call this can start a new game. It's important to make sure that we name our tests appropriately so that as they fail or when they fail, that we can identify them easily. We don't have to go back looking through code or looking, grepping the logs to find out what failed. So in this case, we want to take a game equals new game. And then we want to perform some type of assertion. I'm going to make sure the game is not null. Okay, so this is what we call the red stage. or the failed state. There's two laws as far as test-driven development. The first one is that no production code, we write no production code until we have a failing test, which is what we have right now. We have a failing test because we have compilation errors. So let's go ahead and fix our compilation errors. The second law is only write enough code to make the test pass. Well, in this case, we just have to implement these things here. So we need to create a class called game. All right, that cleared the one. And then we need to import our assert not null. Okay. So there are three stages of, three phases of test-driven development. There's red, green, and refactor. Red is a failing state. So when you write your test with no code behind it, with no production code, that's called the red stage. Or if you have compilation errors, that's the red stage. Green is when your test passes. Okay, we'll talk about third stage, refactor, here in just a minute here. So the next thing that we want to do is we want to do the next simplest thing. We want to make sure that we can roll a ball. Okay, so we have game, close new game, roll ball. Oops. All right, so we're red again. We want to get this to green. All we have to do is create the method roll ball. And we're going to add to this int pins and this is a void function here, or a void method. We'll just put a 0 in there for now. And we are green, so it doesn't return anything. There's nothing really to test. We could perform an assert not null again, but that doesn't make that much difference. Okay, so now we're green again. The next phase would be refactor. So let's take a look at these two tests here. We have a lot of duplication. First of all, we have game. We create a new game each one. Don't need that. So we're just going to go ahead and get rid of this one. Okay, and clean up my import. We're not going to use that one again. And we're good to move on. Now let's go ahead and clean up our board here. Split move right. This is the way I like to work. It helps me see what's going on if I'm writing a class like this. So the next thing that we want to do is we want to see if we can score a game. So how about we try and see if we can score a gutter game, score a game where you roll a gutter every roll. So we'll do that. Can score gutter game. All right, so what is a gutter game? Well, it's when you roll the ball 20 times, you don't get any pins down. So let's just set this up with a loop. We could run functional Java here if we wanted. We could do lots of different things, but let's do it the easy way. Oops, we forgot. We're going to roll all zeros. And then we're going to perform an assertion here. Zero. All right, we are at the red phase again. Let's go ahead and get these in here. Assert equals comes from Jupyter. Oops, that's wrong. API dot assertions star. That's better. All right, and we need a method called score. So let's think about this. Think really hard. What's the easiest way that we can make this thing pass? Ready? Everybody say it at once. Return 0. That seriously is what we do, folks, here. We want to make this pass the easiest way possible. We're not going to release this code today. We're in a process of getting to a point where we can make this thing work. All right, so now, what is the next game? How about a game of one? A game of ones. Oh, let's do some refactoring first. We don't really need this because we're doing everything in the next one. All right, so for I, 20 times. And we'll do an assert equals. So a game of 21s, 21s will equal 20. Game.score. All right, so now let's go ahead and watch this fail. And it does fail. And it fails because the get score is 0. And that's because we don't have anything to collect the score. So let's add that int, our private int. Equals 0 to initialize it. And then we'll say score plus equals pins down. And then instead of returning 0, let's return the score. And we'll run all the tests just to make sure. And we're good. Okay, a little refactor time here. We keep repeating this game thing. I'm getting tired of typing it. So why don't we go ahead and create a field on that. Refactor, introduce field. All right, and let's initialize this field in a setup. We could just say game equals new game, but the problem with that is that every test that runs is going to get the same game. And then we'd have to reinitialize the game score to 0 every time, which we don't want to do. So if we initialize the game in setup, then every time a test runs, it'll get a brand new game. And now we don't need that. Run our test, make sure it all works. And you say, but Rob, what about our for loop? Well, I've seen guys that change this, but I don't think that's important. How you do this is not as intricate as far as what happens in the test here. So we're going to leave that. So now we get to the fun part. We want to do a spare. Then gutters. All right. So, what would a game followed by a spare followed by 3 gutters? Well, it would be a game, roll ball. Let's just say a 5. And we'll repeat that. Oops, and let's say the third ball, we'll make it a 3. And then 20 minus 3 is 17. 17 times. So what would the score be? It would be 10 for the spare, plus the 3 bonus, or 13, and then 3 more, which would be 16. So we would have assert equals 16 game dot score. All right, let's go ahead and run this. And we fail. And we fail because we don't have a concept of frames or anything like that. So we have to start building that in. Now, so the way we do that, we're going to have some type of way to collect each roll so that we can recreate the frames. So we can create an array. Oops, T. And the most you could ever roll is 21. All right, and then we have to have some way to keep which roll we're on. All right, we're not going to need score here anymore because we won't keep track of it there. Now, instead of keeping track of our score there, we're going to actually put it into our array. Rolls at roll. We want to increment that after each one. Equals pins down. Now, we will have our score here. And we need to have something to count where we're at. And now we need to loop through it. Why is that? Oh. Doesn't matter. It would fix it. We'll fix it here in a minute, but we'll do it now. So we'll do for I. We'll do frames. Frames less than 10. So in the case of our basic here, the first, our gutter game and our game of ones, we have pins down, or score, plus equals rolls at cursor plus rolls at cursor plus 1. And then we have to increment our cursor. Like so. Let's go ahead and run all our tests, make sure we get all but the one to work. I usually mess up on one of these. Looks like we're good. And all we're missing is the spare now. All right, so let's think about a spare. A spare is when rolls at cursor plus 1 is equal to 10. And if that happens, the score plus equals 10 plus rolls a cursor plus 2. All right. Now we have to increment our cursor as well. Here we go. And then we need to put our else here. Fill everything out. And let's go ahead and run our tests. And we are in green again. So the next one is we want to score a strike. So in this case, let's do can score strike followed by 2 threes, then gutters. All right, so if you do game, roll ball, you have 10 for the strike. And then we'll have threes. And then we'll have, instead of 17, because this took up 2 balls, that's a total of 4 balls, that's 16. So for I, 16 times, we're gonna game full ball 16. Oh, not 16. That would be bad. Roll zeros. Now, what would the score be? That would be 10 plus 6 is 16 plus 6 is 22. So assert equals 22 game dot score. All right, where are we at here? And we fail because we're at 16, not 22, meaning we don't have a condition for it. We can go ahead and add that. Equals 10. Then score equals 10. Oops, 10 plus now we only want to increase our cursor by 1 because we only consumed 1. All right, let's run this. All right, now I forgot to do some refactoring in here. Let's go ahead and do the first one here. Whoops. First one is a spare. So we're going to go to refactor, extract method. All right, and then this one would be a strike. Make sure we didn't break anything. didn't. All right, so let's go all for it. Can we roll a perfect game? Okay, so a perfect game is we roll 10 tens. Then we'll have to roll 2 more tens in the 10th frame because we have to get our bonus points for the 10th frame. So that would be for 12 times. Roll 10 of them. And then we want to assert equals 300 game dot score. All right, here we go. And that is how you score a game of bowling using TDD in Java. All right. Thanks for listening.